Hello and welcome back. Now that we hopefully have an understanding of scale from last week's project, we're going to move into orthogonal drawing this week. In order to help us with that, our cube is back. Our black cube is taking a bit of a hiatus this week, but its friend, the blue cube, is here instead. What we're going to talk about this week is representing this three-dimensional object in two-dimensional space. And you should bear in mind that while a cube is very simple, the cube represents any three-dimensional object. So, if I were to ask you to draw this cube, likely what you would do is create something like this, which would probably be a perspective drawing, which you should have done or in the middle of doing, perhaps in other classes. The perspective drawing represents what the cube actually looks like. In the perspective drawing, you can see multiple sides of the cube at the same time. You can get a feeling for the mass or volume of the cube. So if I wanted to show someone what the cube looked like, a perspective drawing would be a good way to go. However, if I wanted to have someone build the cube for me, the perspective drawing might not be the best option. And why is that? It's because perspective inherently has distortion built into it. If we look at the cube, we'll remember that because it's a cube, all of the sides are the same size, all of the angles are the same, and they're all 90 degrees. However, if we look at this perspective drawing of the cube, you'll notice that the sides are not the same size, the angles are not all the same, and none of them actually are 90 degrees. So this is not a good drawing to give someone to ask them to build this cube because they can't take any measurements from it, because it's inaccurate, it's distorted. So how do we solve that problem? The way we solve that problem is by taking our cube and unfolding it, so that we have all six sides represented at the same time in a straight-on view. So this unfolding imagines that we're looking straight at the front and straight at the right and straight at the back, etc., all at the same time, because we've unfolded the cube. This is the basis of orthographic drawing. If you didn't yet watch the videos in Project Zero from last week about orthogonal drawing, you should go back and watch them now. If you have watched them, I will just say that there's one slight deviation. Here in the United States, we use what's called third angle projection. The rest of the world uses first angle projection. That is explained in the previous videos. However, there's a sort of a special case that we use in architecture and design, a special case of the third angle projection where we put the plan underneath the front rather than on top. That's just the sort of the convention, because in the U.S. we like to do everything differently. We have to work in inches and feet rather than metric. Anyway, I digress. So this unfolding of the cube is the basis of the orthogonal drawing, which would look like this. So now I have represented the cube with several different views that are in fact true size and shape. So the sides are all the same size, the angles are all 90 degrees. So I could, and this is drawn in scale, assuming this is in quarter-inch scale, this would be a 7-foot square cube. So now I could actually send this to someone and say, please build this for me, and they could take measurements from this. They could determine, if I told them what scale it was, how large the sides were, that all the angles were 90 degrees, etc. So an orthogonal drawing is a much better way of representing an object in order to have it built, whereas the perspective drawing is better for showing people what things look like. So in terms of theater and themed entertainment, perspective drawings are probably what you're going to want to show the director or the producer or someone who needs to approve what your design looks like. But orthogonal drawings are probably what you're going to want to send to the shop that's building the object. They actually are also probably going to want to see the perspective, because they can get a better idea immediately of what it looks like from the perspective, and then they can reference that when they're looking at the orthogonal drawing. So why do I have multiple views of this object? Well, clearly, if it were in fact just a cube, I would only need one view of it. But remember that I said the cube represents any three-dimensional object. And with most three-dimensional objects, you need at least two. usually 3, and sometimes more views in order to fully describe the object. You almost always need a front view, and then you usually need a side view or a plan view, and usually, often, we do all 3. Why is that? Why do we need different views? Let me show you by drawing a front and a side view of 2 different objects. So here is a front view of an object. Here is the side view of that same object. Here is the front view of a different object. And here is the side view of that different object. And so far these look identical, right? So let me show you the actual object now, or objects. Here are the 2 objects from the front. Here are the 2 objects from the right. So far they look exactly the same. They look like squares. It's not until we rotate and look at the top that we see that these are in fact 2 very differently shaped objects. We have a cube and a prism. So in order to fully describe these objects, I need to add the third, I didn't leave myself room really, but I need to add the third view. So if this is the front and this is the side and this is the top or plan, then this is the front, this is the side, and then of the prism, this would be the top or plan. Hopefully that makes sense. You should also be aware that this is not just for sort of planar objects like this. If we're looking at, because we don't have shading really in orthogonal drawing, if we look at the front of these 2 objects or the side of these 2 objects, you can probably already tell that this object is on the right is round. But if there was no shading, this would just look like a square, just like this. So in order to fully describe the cylinder, you have to have really 2 views. If you have the front and the top or plan, you can describe it. The side of a cylinder doesn't even really make any sense. So where does one side stop and the other side start? But you have to have at least 2 views of this particular object. So hopefully that makes sense why we need multiple views when we're in orthogonal in order to represent an object. And bear in mind, as we're working through the exercise this week, the cube is representing any object, so we're going to draw a more complicated object than a cube. But I often like to sort of use the metaphor of thinking of the cube as a glass cube and imagining that whatever object it is I'm drawing is inside that glass cube, which sort of sometimes helps me to remember that the drawing metaphor is you put the object inside the glass cube, you stand in front of it and draw on the glass what you see from the front, and then you walk around to the right side and you draw on the glass what you see from the right. You just have to remember that you're not drawing in perspective. You're drawing in straight on views. So with that said, we will move on to this week's project. The project this week is for you to find an object, and I'm going to suggest that it's something on the scale of a piece of furniture, so not an iPhone and not a football stadium. You're going to find an object, measure it, and create an orthogonal drawing of that object. And in order to demonstrate that, I am going to create an orthogonal drawing of this chair. I've chosen this particular chair very carefully because it is quite square. And therefore I don't have to draw any round parts. And I would encourage you, unless you're very advanced, to also choose something that's pretty square. I should say now, though, and I think I mentioned this last week, that what we're doing these first couple of weeks isn't really drafting. In order to really hand draft, you need tools like a T-square and a triangle and templates to draw different shapes and a compass and all sorts of things. So we haven't asked you to buy all this stuff. So we're really not attempting to teach you how to hand draft. We're really just teaching you the language of orthogonal drawing using paper and pencil to start so that you have a better understanding of it when we go into CAD. So that's why I'm suggesting find something that's square. So that a table, a dresser, a kitchen counter, kitchen cabinets rather, something that you can see multiple sides of and that you can get to measure, but it's not, let's not do the Pegasus sculpture outside of the honors college. Probably not a good thing to try to do an orthogonal drawing of. So the end goal here will be something like this. This is my orthogonal drawing of this chair. And this particular object needs 4 views to fully describe it. The front, the right. I need to draw the back of the chair because there are these stretcher pieces that you can't see in any of the other views. And then I've drawn the plan not so much because I necessarily need it. You could construct this chair from just the front, the right, and the back, but because if I have a chair, I'm probably going to want to include it on a plan, a ground plan or a floor plan somewhere, so I need to see what it looks like in plan. So I went ahead and included the plan. So how did I start this? Well, I started by measuring the chair. So I made a quick, not even anywhere near accurate sketch of the chair, and then I took all the dimensions I could think of using my tape measure of the chair. So I sort of sketched out the front, the side, the back of the chair. I made measurements. I included some details that I thought I might need. I decided to simplify the drawing when I did it and not include the details like the groove that's running down the middle of the chair, because I discovered in the scale that I ended up drawing it in, those details really weren't necessary. So this is where you should start. You should take your object, you should do a sketch of it, and measure everything that you can think of. Now, part of the reason that I'm asking you to do something that you have access to is because even though I took a lot of measurements, I found myself going back to the chair a couple times needing another measurement that I hadn't thought to take to start with. So you're going to want to have easy access to the object because you too will probably discover as you're drawing it, oh wait, I need another measurement. So that's where you should start. Measure the object and write all those measurements down and make a quick sketch of the object. The next thing you'll want to do is figure out what scale to draw it in. So in order to do that, I need to look and see what size my different views are going to be. So I can see that because the overall width of my chair is 24 inches and the overall height of my chair is 34 inches and the overall depth of my chair is 27 inches, I can sort of start with those numbers. So I'm just going to make a quick sketch. And I know because I need to put 3 things side by side, I need to turn the paper in this direction. If I'm only doing 2 views, I might need to turn the paper in that direction. So one of the first things you do when you're creating a drawing like this is sort of sketch out where all the parts are going to go in the paper before you start. So I'm going to start by just saying that I need a rectangle that is 24 inches by 34 inches. And then another rectangle that is 27 inches by 34 inches. And then another rectangle, so the back is going to be the same as the front, 24 inches by 34 inches. And then if I'm going to do the top, the width of the top is going to be 24 inches. And then the the width of the plan is going to be 24 inches, and the depth of the plan is going to be the same as the width of the side, because this is in fact the side, so 27 inches. So I need to find a scale that will accommodate these size rectangles and figure out what that scale is that will fit on the 8.5 by 11 piece of paper. So I'm going to take my scale rule, and the sizes that I just sketched are probably about the right size. I want to make sure that they're small enough that I can leave some space between them, but they're large enough so that I can get some detail in. So if I were to, let's just arbitrarily look at 1/4 inch scale. So this, in 1/4 inch scale, this is 8 feet, and it needs to be 2 feet. So 1/4 inch scale is too small. If we look at 1/2 inch scale, that's 4 feet, still too small. So let's try 1 inch scale. Oh, look, okay, so 2 feet. So that sort of fits. 34 inches is close to 3 feet. So 1 feet, 2 feet, 3 feet. I didn't quite draw this accurately, but that should work. 3 feet here, 1, 2, 3, that's gonna work. All right, so it seems like 1 inch scale is gonna work for me. If I were drawing perhaps a desk or a table or something that was wider than the chair, probably 1 inch scale is going to be too big. Probably 1/2 inch scale is going to work. But whatever it is you're drawing, sketch out the rectangles that will contain the object, and then figure out what scale will work given the 8.5 by 11 piece of paper that we're working on. I am going to tape my paper down to my drawing surface. You don't necessarily need to do this since we're not using T-squares and that sort of thing, but I find it helpful. Then I'm going to sort of lay out lightly these rectangles. I'm going to figure out where they need to go, and the rectangle is not going to be part of the object, so I want to lay it out in pencil lightly so I can either erase it when I'm done or just lay it out lightly enough that it can stay. So referencing my sketch again, I know that I need to establish where on the top of the page I can fit 34 inches, which I'm just going to kind of round up to 3 feet for right now. So it's 36 inches. So in my 1 inch scale, I always turn these around. If I start at this line, then 3 feet would be here. So 1 foot, 2 feet, 3 feet. So I'm going to establish this line as the baseline. Just going to lightly draw this in for my chair. And then 34 inches, which is 2 inches less than 3 feet. And so I'm going to put my scale rule here on 2 feet. So I'm going to go to 0, and then 2 inches less than 12 inches is going to put me here. So I'm going to draw a little dot there, and then 2 feet, 10 inches, which is here. So then I can draw, oh, just hit the camera. Then I can draw that line. So that's going to establish the bottom and the top of the chair. And then I'm going to sort of, in order to lay this out on the page nicely, I'm going to start with my center rectangle, which is 27 inches, and I'm going to draw that in the center of the page. So half of 27 is 13.5. So I'm going to find the center of the page using the actual ruler. So it's 5.5. So this is my center line. I'm going to just lightly draw that in. I'm actually probably drawing these darker than you should so that they show up on the video. And then I'm going to go 13.5 inches on either side and 1 foot scale. All right, 1 foot scale. So 13.5 inches. That's 12, 13.5, and then 12, 13.5 in this direction. And I can either measure at the top, or I'm going to tempt fate and just line my ruler up, because once again, I'm not really drafting. If I was really drafting, I would do this with a T-square. I'm going to draw that, and then I'm going to draw that. So that's the boundary of my center drawing. And then I think I'm going to come over 1, 2, 3, maybe 5. So I'm going to start here. I'm going to give myself enough room between the drawing. So now I'm doing 24 inches. So if I start there, and this 5 is just arbitrary. If you need, however much space you have, just kind of try to lay it out so it fills up. I'm going to go 2 feet, 2 feet, which brings me to here. So it's nice and falls on one of my lines. So, and I'm going to go ahead and take this one all the way down. And I'll explain why in a moment. So if I line up here, take that one all the way down. Then I'm going to go 1, 2, 3, 4, 5 in this direction, because the back is the same size as the front. And I'm going to measure 2 feet. Takes me to here. So then I'm going to establish that line and that line. Then I'm going to come down 5, 1, 2, 3, 4, 5, and establish the top of the plan view. And then remember we said this distance is equal to this distance, which was 27 inches. So from there, I'm going to go 2 feet, which is 24, plus 3 is 27. So, from there, 3 inches plus 1 foot plus 1 foot, that brings me to here. 24, 25, 26, 27 inches. So I'm going to draw that. So what I have, just so you can see it easier, I've inked this in, is these 4 squares. This is going to be the front, this is going to be the right, this is going to be the back, and this is going to be the plan. Do not darken in your squares or label anything like this. These squares are not going to be here in the final drawing. These are just showing me the places where I'm going to put my drawings so that they're laid out nicely on the page. Now that I have my place to put my 4 drawings, I'm just going to start making the drawings. So I'm going to refer back to my sketch, and I'm going to see that the frame of this chair, all of the legs and arms and things, are 1.25 inches wide. So in this front view, I need 1.25 inches arm basically on either side of my rectangle. So I'm going to take my 1-inch scale. I'm going to find 1.25 inches, which is actually a little, this probably would be easier to do this on a larger scale, but it wouldn't fit on the paper. So there's 1.25 inches there, and there's 1.25 inches there. And I'm going to carefully line this up. Now, if I really wanted to, I could measure 1.25 inches at the top so that I could, connect the dots and make it, make sure I was being absolutely straight or plumb with it. But for what we're doing here, I think this is close enough. So, and you notice what I'm doing is because I'm doing that, rather than putting it on this side and covering up the line I'm trying to be parallel with, I'm putting the straight edge on this side so that I can see the line that I'm trying to draw parallel to. So now I've drawn 1.25 inches here, 1.25 inches there. And the height of these side pieces is 25 inches. So I'm going to find 2 feet, which is 24 inches, and then go up 1 inch from there. And I think in this case, I actually am going to establish that on both sides. So 24, 25. So I'm going to draw, and once again I'm putting this closest to the blue line so I can see that it's parallel. I'm going to draw that. So that's the top here. Then 13 inches from the bottom, there is a, sorry, let me move this over so you can see it. 13 inches from the bottom, there is a 2-inch thick spreader that goes across the bottom. So I'm going to find 1 foot. I'm going to go up 13 inches, which is 0 plus 1. And then I'm going to go up 2 more inches, which will take me to 3. So that ends up actually right on the blue line, which is nice. So you can go there, and then this one, we're going to go there. Okay, so that gives me the spreader. Then my and you'll see that my drawing was way off. There's this would be a very low seat. The cushion is 3.5 inches thick, so I'm going to start from here and go up 3.5 inches, which is just above the blue graph line. Okay, and then the top of the cushion should be at 34-inch mark. So now I can, I'm going to go ahead and darken this in. I'm just going to continue that line so that we can see what, or hopefully you can see what this looks like. I'm going to do this in pen. Well, no, I'm not. I'm going to do it in pencil because you've got a pencil. So let's see how dark we can get this. So I'm going to draw the top of the cushion. And when I learned to draft, because by hand, because there would be a T-square, I typically do all of the horizontal lines at one time and all the vertical lines at one time. There's no, when I'm darkening things in, there's no real absolute rule that says you have to do that. It's hard for me to tell how much my head is in the way of the camera, so hope I'm not blocking too much of this. And then let's see, this would be the top. All right, then I'm going to draw the sides. And here I can actually go all the way up. Come over here. And, oh, I should not have gone all the way up there. It's a good thing I did not do this in pen. Actually, I'm going to erase some of that. So you'll see that is what the front view of my chair looks like. So that wasn't so hard. So now I'm going to draw the side view. So I'm going to start by establishing where this frame is, because it's the one square thing in this drawing. So it starts 2.5 inches from the absolute back of the chair. So from the back of the cushion to the back edge of the frame is 2.5 inches. So the back of the cushion is going to end here. So I'm going to measure 2.5 inches in the right scale. 2.5. It's really not, I guess. Okay. So 2.5. So there's my 2.5 inches. So now I'm going to establish this frame, which is 21 inches wide. So from this line, I'm going to go over here 21 inches, which is 12 inches, 15, 18, 21. So it's going to go to the 9. So 12, there's 21. Going to draw that line. And because the top of this is this, it's right, it's the same thing. This is the front of this, and the top of this, they're the same thing. So I've already established this in this other drawing, so I can line this up and establish that the top of that is right there. So I didn't draw the line quite far enough here. There. So this 21 inches is the outside dimension of the frame. So now I'm going to go back and draw in the 1.25 inch. All right, wrong scale. 1.25 inch width. 1.25 and 1.25, which is going to put me right on the line there, which is handy. So I can draw that, and then this, and this. All right, so that establishes my framework. So then next, I'm going to draw in this spreader, which is 2.5 inches high. And we already know from this side of it, because it corresponds to here, that's 13 inches. So if I go up 13 inches, which is 12 inches plus 1 inch, so that's 13 inches. And then I'm going to go up 2 more. Wait, I said it's how tall? It's 2.5, so I'm going to go up 2.5. And then on this side, it's 11 inches. So we're going to go 11 inches. So 0, so 11 will put us right there. And then 2.5 above that will put us right there. So that is our spreader, or side stretcher, depending on. All right. The next thing I think I need to look at is this cushion. So what I need to know is how far this point is from this point. I think this is one of those dimensions that I forgot to take, and I went back and measured, and what I discovered was that it's 7 inches from the absolute back to where this cushion starts. So I'm going to measure in 7 inches from this line. 6, 7, so that's where that starts. And then it goes from there to the very back, to this point here. So although it should go through, seems like it should go through that frame, doesn't it? Something is amiss here. Oh, I see. All right. I'll explain why I was confused in a minute. I was trying to figure out how this went through the frame, but that's why I need the back view, because there isn't a piece at the top here that's holding this up. The piece is down further. So then this is 3.5 inches thick. So 3.5. And as I mentioned, after a while, you're probably going to say, I'm not drawing this chair. Why am I watching all this? Once you get it, and you can stop watching me and start doing your own. Oops. Doing your own object. Put that there. Then we know that the cushion goes to the front of the box, the 27-inch box. So the cushion sits on top of this stretcher, so it goes that far, and it's 3.5 inches thick in the right scale. 3.5, 3.5. So it looks like that. And then it is square. All right, so looks like that. So now I can darken all of that in. Sometimes with chairs, the back sits on top of the front, and sometimes the front stops at the back. I was just looking to see which. And I may have got this backwards. I should actually not look at my sketch. I should look at the photograph of the chair, but I've committed to this already. So I'm going to go like that. So square it off. This is also actually probably, yeah, this fabric comes down because in reality the foam would be square, but the fabric comes all the way down. I remember looking at it now. So this, and you'll notice that the cushion is behind the frame, which is why I'm stopping the lines at the edge of the frame. And then we're going to square that off. And I'm just going to do a little bit of cleanup here. Mostly I'm going to leave the layout lines, but that was super confusing. So now I'm going to draw the back of the chair, which is very similar to the front. So I know that the top of the frame is going to be here because it's going to be lined up with all the other tops. So that's this. These are going to be 1.25 inches, as they always have been. So 1 inch and a quarter, 1 inch, quarter. Gonna establish that. And that. Oops, wrong button. Now we know that this is 2 inches, and it corresponds to this. So the bottom of it is going to be here. And then it's going to go up 2 inches. It is thinner than this 2.5 inch piece. So that's that part. And then there's this piece. It has to be right here, because if the top of it has to be right here, because it would be here, and this leans against it. If it was any further, then the cushion would be trying to go through it, right? So the top of it corresponds to where the cushion sort of intersects the leg, and then it is 1.25 inches thick. So there. Probably the safest bet would be to actually go back and measure that. But all right, so that's what that looks like. The cushion keeps going to the top of the chair, but so I'm going to go ahead and I'm going to start on this side. I'm going to go ahead and darken all of this in. Okay, so here the cushion goes all the way to the top. Here, cushion goes all the way to the top. Get some more lead. There. Top of the cushion. The top of the arms. Top of that stretcher. Top of that stretcher. I'm going to do a little erasing here. Just a little. All right, so that's what the back of the chair looks like. And then the front of the chair is going to look, oh, whoops, I missed one line. So you can see actually the top of the cushion because it's lined up like that. So this is this, which is the top of the cushion that you can actually see. So now the top of the chair, the frame starts this far back. So I believe we decided that was 3.5 inches. So 3.5 inches. All right, so 1.25 inches, or I can just line this up because I've already drawn it above. So here and here. This was 21 inches, if you remember that. Or you can go back and look at your notes, 21 inches. So 12, 15, 18, there's 21. 21. What else? So the cushion comes forward to the front. So it comes forward like that. So just so I don't confuse myself, that line doesn't actually exist. The depth of the cushion, so this point is 18 inches, 1'6" from the very front. So 1'6" is on that line. So there's the depth of the cushion. And then this distance is right at 3 3/4. So it's right there. So that's the top of the cushion in that view. So then it's just a matter of darkening all of this in. So top of the cushion, more lead. The back of the top of the cushion. This is the front of the top of the cushion. This is the back of the arm. This is where the two cushions meet. This is the front of the arm. This is the front of the cushion. And then this is the side of the arm. This is the side of the arm. And then the cushion continues there and there. So I can erase that and that. And there I have my 4 views of the chair. So now I just simply need to label them. So this is front, right, back, plan, and then an overall label of chair. with a scale of 1 inch equals 1 foot 0 inches. And then I'm just gonna do that. All right, so you should end up with something that looks like this. Whatever your object is, however many views you need. Many of you will only need 3 views. Many of you will only need front, one side or the other, and the plan. You probably won't need the back. But if you do, add it in. Select your object, measure it, figure out the overall size of things, to figure out how to scale that to fit it on the page, and draw in your boundaries, and then sketch it, not sketch, draw in the rest of the object. There we have it. So good luck.